Alright, so let's finish up talking about weight a little bit. So in the last video we saw that weight is a force. It's a force due to gravity. So if you were going to calculate weight, you would just calculate the force due to gravity. And then we saw, well, there's really 3 different ways you can change your weight. Way 1 is actually change your mass, which would be kind of like, I'll say, working out, right? Building up muscle mass. Way number 2 is to measure your weight on a planet with higher mass, right? So these two different methods could be said as increasing mass 1 or increasing mass 2 in this equation. And the last one is just the last thing that's left, which is you could decrease your distance from the center of the planet, which would be lowering R. And these 3 ways would all make you gain weight. And so that also means that if you went up higher, right, if I increased my distance from the center of something, so maybe I'm on top of a mountain now, you could actually lose weight. And this is why mass is really what we want to know when we go to the doctors, and not weight. So let's do an example. So let's say you leave the surface of the earth and you go out, let's say 1 times 10 to the 6 meters away from the center of the earth. And I remember that the radius of earth is 6.378 times 10 to the 6 meters. And I want to know, for a 60 kilogram person, how much weight do you lose? Remember that the earth's mass is 5.97 times 10 to the 24 kilograms. So let's set this up the normal way. So force of gravity is G m1 m2 over r squared. If I plug in my values for if I were on the surface of the earth, here I go again, erasing my own problem. Oh, I know what I'll do. Ready? Times 60 kilograms times 5.97 times 10 to the 24 kilograms divided by the normal radius. We'll just do the normal surface weight squared. And we'll get 587 newtons. So let's redo this calculation, but with our new R. So it would be 6.67 times 10 to the negative 11 Newton meter squared over kilogram squared. Right, the masses aren't changing here, so 60 kilograms times 5.97 times 10 to the 24 kilograms divided by, okay, here's the different part. Our R now is this whole distance here, okay? So it's going to be 6.378 times 10 to the 6 meters plus 1 times 10 to the 6 meters. That whole thing squared. And that's going to give us 439 newtons. So you can see that just by kind of increasing your R, right, moving up more away from the Earth's center, we're losing quite a bit of weight. But your mass stayed the same the whole time, because weight is a force. And the force is decreasing because R is increasing.